Looks good. All right, testing. Cool. We're going to be learning about the exciting world of variable types, variables, and standard input and output. There is a little bit of caveat I want to talk about. A lot of these things are pretty basic and rudimentary, of course, but these are the building blocks about how you learn to do everything. I still use these things every day in programming, even though I learned them probably like 12 or 13 years ago. These things are kind of specific to C++, but these are ideas that you can kind of use in any programming language, whether you're using Script or C# or whatever. These concepts are kind of common throughout programming in general. So it's not something that is just for C++. There's a couple things we're going to be doing. See that? All right. Here are the things we're going to be doing today. And this is kind of out of the book. I'm going to be putting a little bit of a twist on some of them. We're going to be making a few programs today. There's going to be several. And they're going to be pretty simple, but these are the kind of main points about what things that we're going to be trying to accomplish today. Mostly trying to show things in an output window. You're going to be typing up in text. And the goal is to get something to show up on screen, kind of like what you guys did for homework, right? You're also going to be doing some basic arithmetic, like really simple like calculator stuff. So like exciting like adds and subtracts and multiplies and divides. The best part though is that you get to have the computer do it for you. So these basic arithmetic operations, I mean, obviously we use them all the time. Like ranging from things to like, oh, you need to deal 10 damage to this thing, or you need to give this guy a level up, right? Or you are even trying to figure out like how much XP you need to gain another level, right? Those things are basic arithmetic. You use them everywhere. They're kind of just in any piece of code that you have for games, you're going to be doing some arithmetic. So we're going to start with that. Using variables to store, manipulate, and retrieve data. So I'm going to talk a little bit more about what variables are and why those are important, but variables are kind of like the bread and butter of programming. So it's pretty difficult to make a program without variables. Variables are just a way to basically store information in your game or in your program. You'll also be able to figure out how to interact with the user. So this is the kind of caveat that I want to talk about too, because we're going to be making console applications, so we're going to be making the black screen with like plain white text, you know, simple stuff, and you're going to be like having to type in stuff into the console. I know it seems kind of simple, but this is one of the easiest ways to get input from the person sitting at the keyboard. Now, normally when you're playing a game, how do you get input from the player? Controller, keyboard. Mouse and keyboard, right? WASD input, right? You're not like typing move forward or anything like that. You're not, but you are pressing buttons, right? And you are like pressing keys and clicking the mouse and stuff. So even though the way you get input when playing a game is different, even though you're like clicking a mouse button or pressing a trigger on a gamepad, that ultimately still gets to your program, and your program has to figure out how to deal with that. What we're going to be doing today is dealing with letters and words that you type in and numbers that you type in, but that could just as easily have been a button that you would have pressed that causes some behavior to happen. Okay? So we'll get into more of that next week as far as like how to handle what to do based on what button you press. So like, oh, A would make you jump, or like right trigger would make you shoot, right? Or the left analog stick would make you move. But today we're going to be using the input system that's built into the console, which is just basically let you typing in numbers and strings and letters. Letters and strings, which I'll get to. Constants and enumerations. So these are basically ways to define values. It's kind of like, let's see, level cap would be a perfect example in World of Warcraft, right? Or any MMO. A lot of MMOs have a level cap. You hit that level cap, and that's it, right? So a constant is a way to define a value that's kind of common throughout your entire game. So like a level cap in vanilla WoW would have been 60. So somewhere in WoW was a constant that says, hey, max level is 60. Or starting health in like an adventure game like in Skyrim, or how much strength you have for this specific class, right? These are things that are kind of defined ahead of time that you use in your game repeated times. And then strings. Strings are just literally, think of if a character is a single letter, so like A, B, C, D, a string is basically a collection of those. It's literally like you're stringing together those characters to form a word. So strings are just multiple characters put together. All right? Any questions on that stuff? I want to talk a little bit about why C++ is used for games too, because I think that it's a little bit weird nowadays. You might see a bunch of programming classes, or you might even look on the internet like learning programming, like how do I learn? And there's a lot of stuff related to like learning web-based programming, so learning JavaScript, HTML5, you learn CSS, you can learn C#, or you can learn Visual Basic. There's a lot of ways you can learn programming, so why C++, right? Why do you guys think the game industry uses C++?
Because of Windows?
No, Windows has actually nothing to do with it. You can program in any language on Windows pretty much.
It was really fast in the
For graphics?
Yep.
but
That's one of them, yeah, because speed is one, yeah. What do you think?
Flexible, and it's also well supported.
Yeah, so those are all really good things, but like, I think that there's a big history to like programming in the game industry, to me. If you think back to like when game industry started, like the Super Nintendo era and like Nintendo era and Atari, a lot of those games were built without any kind of like programming language. A lot of them were built using what's called assembly. So these guys were literally typing in like the things you would see would be like 4 characters like JMP and then like a number after it, and then you do like that 1,000 times, or like CMP or like JNE. Like these are like shortcut characters that represent lines of code essentially. Evolving from that, like there was a guy that wrote C. It was originally written because it was designed to make operating systems, but from C came this other language called C++, which was written by this guy Bjarne Stroustrup. He's kind of a kooky guy, but he's still alive. The guy that invented C++, he's still alive and kicking, and he gives lectures on C++ all the time. He's always actually looking to improve the language. The latest version of C++ is C++ 11. C++ 14 is the latest version. So I want to talk about why that is important in the game industry. It's fast, for one, right? There's not really any other language out there that can compare with C++ in speed, with the exception of maybe C. And some people do program games in C. And then you have assembly after that, which is not really like a standard high-level programming language. It's not really a programming language that a lot of game studios use. You might write snippets of it. But regardless, C++ is used because, one, a lot of people are already using it because they were using C before and then they moved to C++. So there's a lot of history. A lot of game developers had been using C++ for a long time. It was fast. And all the tools that were built around programming are really, really good for working with C++. Especially with regards to consoles. When you're making a console game, it's actually kind of, you might have known this a little bit already. If you guys ever played like a console port of like a PC game, right? Sometimes those console ports are not quite as good, right? And some of that's due to the hardware, right? Like you don't have enough memory to like have the high-res textures, right? Your textures on a PC can be much, much higher res. But a lot of it also comes down to that you need to make these games run on like kind of hardware that's about like almost 5 years old, if you think about it, like in PC terms. Like our PS4s and Xbox Ones are on pretty old hardware nowadays, like if you compare it to like a modern PC. So like a lot of it comes down to trying to maximize the use of that hardware to really make it run as fast as possible. And C++ really is the key language for that. You're not going to be able to do that with any other language. Specifically, the reason why is that C++ doesn't like, it doesn't mess around. Like it doesn't hold your hand really as far as like what it expects that you know what you're doing. That's the reason why it's both like really good and really dangerous in a lot of ways, because a language like JavaScript or C#, these are like languages that you might use to make like an app or something on a web page. Those languages try to make it easy on you. Like they hold your hand. They say it's okay if you do something wrong, nothing bad will seriously happen. We'll take care of it, and you'll eventually recover and you'll be able to keep going. Like if you make an error in your judgment, like you try to do something that's not supported, it'll be okay. C++ is like the really strict dad. It's like punishing. It'll reward you if you're like doing well, but in reality, it's something that you have to know a lot about it to be able to extract the best performance out of your game. But that's why programming is such a high demand job, because people that know how to do that are few and far between. But it's something that you can really learn how to do. So for me, all Blizzard uses C++. Every single game that Blizzard ships, with the exception of Hearthstone, which is a Unity-based game, uses C++. But even Hearthstone uses C++ for the server side of like the Hearthstone. So when you're playing against other people, and all of our console efforts are all on C++ too. Cool. What's nice though is that nowadays, with the PS4 and Xbox One, we're using Visual Studio 2015, right? You can use Visual Studio 2015 to make console games too. So if you have a license for developing on PS4 or Xbox One, which I think is pretty expensive, Last time I checked, it was something like $50,000 or $100,000 for one of those. Plus, you got to get the dev kits for it. But like, you learn the tool once, you learn Visual Studio once, you learn C++ once, you can take that knowledge and directly apply it to console. Like, the biggest differences between making a game for PC and making a game for a console is that, one, you have less memory to work with, so you can't make as much stuff a lot of times. Although the latest ones have about 4 gigabytes of memory, the consoles do, so that's a ton compared to the PS3, which the PS3 had 256 megs of memory for video and then 256 megs of memory for system. Which is like nothing. Like, can you imagine only having 512 megs of RAM nowadays? Like, that's crazy. Yeah, like when you're developing for console, a lot of it comes down to like, you have a lot of functionality available to you, like Xbox. One of the things in Xbox One that you can do is you can just record gameplay as part of it, or you can say like record that, which will record what you had just done. So yeah, you can invoke that stuff. Just like how last week, I don't know if you guys saw, I caused the CD tray to like eject and come back in. You have that whole library of functionality that's specific to Xbox One and PlayStation as well. So you can do things like that. All right. Oh yeah, and you mentioned it was flexible. I think that is key. Like you can use C++ to make games. You can use C++ to make. They use C++ on the SpaceX rockets, which I was just at SpaceX last week. The rockets that go and deliver stuff to the ISS, all the software that runs on those rockets is written in C++ too. So that's something new because most of the rockets that like were built by NASA run on assembly, which is like the whole like 4-character really weird kind of way to program. It's really difficult. We're not going to be learning any assembly this quarter. So, all right. So now that we know what we're going to be doing, I want to talk a little bit about what it takes to actually make a program. So we're mostly working in text, right? Like it's kind of a world of programming. It's not like we're building together your game by dragging blocks around. Unlike last week, unfortunately, most people don't make games using Scratch or Stencil. It does teach you a lot of the same programming ideas, but there are ways to kind of make games using visual scripting. Like there's newer tools with Unreal 4 and Blueprint, if you guys are familiar with that at all. Unreal 4 has a way to basically visually kind of program. So does Unity as well. But for us, we're going to be working in text. So we're going to be working in text. You can use kind of any text editor you want. You can literally just use Notepad and program if you want to. I prefer not to do that. I like to have Visual Studio help me. And I'm going to get into why Visual Studio is a good thing to use for helping you write your code. But this is basically the path that a program takes from start to finish. So at the bottom of this is an executable. This is literally the game that you run. Everything runs as an executable on Windows, right? So like Call of Duty or like Skyrim or any game that you played on PC, there's an executable somewhere that you can like double click and run. And that ultimately came from some source code that someone wrote somewhere. So there's text files that support that. So everyone's kind of going through the same steps that we are. Even though we're making like a console application, like we're making a black and white window, and it's pretty simple visually, the steps that we're taking are the same. And the difference is that bigger games tend to have more projects, kind of like what I showed you guys last week. There are a lot more projects to bigger games, but the general idea is the same. Someone out there is still writing code, building together the logic for a game, and compiling it, and then getting it down to an executable. All right, so I want to talk a little bit about the steps here. You have your editor. So this is basically any like Notepad or Visual Studio that you want to use to basically write your code. It's basically like a word processor. You can even use Microsoft Word probably if you wanted to program. I bet you could use Microsoft Word. So after you write it and you save your file, usually your file is named specifically. So when you guys made your projects and made your homeworks, most of the time we are specific about what the extension is. So in C++, we have 2 main extensions that we use for a file. You guys know like an extension is like dot something, like .txt or like .exe. So C++ has 2 extensions. One is .cpp and one is .h. So a CPP file is kind of what you guys made. That's what gets compiled. A .h file, you can think of it as more like .h files don't get compiled, they get brought in to a C++ file. So .h file is kind of just, when the compiler runs, when Visual Studio builds your game, all it does is takes the .h file and essentially it copies all the text in the .h file, copies it all, and then does a paste into your CPP. where you include it. So it's just a way to organize files. So C++ uses .h file as a way to organize. We're going to get more into that next week, so we're not going to really deal with .h files yet today, because there are some kind of interesting ways that you have to work around them. You can get like a lot of weird compiler errors when you're working with .h files, so we're not going to really deal with that. So once you compile your CPP file, however many you have, every C++ file gets compiled down into, before it gets to an executable, it goes into something called an OBJ file. So you can actually see these. These are like an intermediate file that the compiler will generate. This is something that basically is like, it's if you're going to be baking bread, for instance, and you're going to be kneading the dough, before you actually put it in the oven, you have to let it rise. So it's kind of like the intermediate step that has to be done before it can actually generate this executable file. And the reason is that you might have like hundreds of thousands of CPP files. We probably have maybe like 30 or 40,000 CPP files on Overwatch easily, not counting all the ones that we automatically generate. And you have to take all those CPP files, and a lot of them have relations to each other. Like we have a CPP file for our camera, which is pretty closely tied to our UI in a lot of ways. But they're in two separate files, but they share a lot of functionality. They work with each other. Like the camera might tell the UI, oh, this is where the capture point is right now. You need to draw the UI right here. Or the UI might tell the camera, hey, I want to do a UI shake. I want to shake the camera a little bit. So go ahead and do that. They talk with each other, which means the game has to figure out how they relate. So what happens is that it takes both of those CPP files and generates OBJs for them. So they're kind of like chunks. You can imagine just like it packets them up in a box, sets them aside. So that the linker could come in later and basically figure out which parts need to communicate with each other, so which parts of the camera and which parts of the UI code need to run together, and then combine them together so that by the time you get to the executable and you run them, all those pieces have been stitched together so that they can work properly in the exe. All right. And finally, you can run your executable by double-clicking on it. It's a lot. You don't really have to know this specifically, because all this stuff happens super fast when you're doing Visual Studio. Like when you click the run button in Visual Studio, it goes through this all at once, right? But there's two distinct phases that you have. One is the compilation of your code. You can get errors here when you're compiling code, and you can get errors here. These are two places where you will get errors in your code, and there's two types of errors that we can talk about. We have compiler errors. These are things like, let's see. Yeah, I don't have any examples here, but that's okay. We have compiler. We're going to get into compiler errors in just a second, too. Compiler errors, and we have linker errors. You really only have to know that this is a problem usually with how you typed out your code. This is usually a problem with you missing something. So you forgot to tell your compiler how two things interact with one another. So when I talked about the camera and the UI and how they interact with each other and like how they know what to do with each other, the linker, in order to actually pull that functionality out and stitch it together, you have to tell the linker how to do that. And it's pretty easy. It's like usually it's either a property in your project, so you go through a property and you add something that's missing, or you include something that is not there. So this is usually a problem not with how you type something, but how you configured your project. And this is usually a problem with how you typed it. So you're missing a semicolon, you have an invalid name, you type something wrong. Those things are compiling errors. Any questions so far? I know this is a lot. It's all just, we haven't even gotten to like the code yet. I'm just talking about, these are the things to kind of expect when you're running your project. Okay, anyone ever run into any crashes or bugs when playing a game? Like you play a game and like the game shuts down and stuff? Yeah. Overwatch also has crashed on occasion too, so there's been a lot of issues with that. Those are kind of an interesting thing because you might do everything right. You might get your program to compile, you have an exe you can click on, cool, you can play your game, you can play Fallout 4, whatever. Then you get down to here and you're actually playing your game and you run into weird problems. Like maybe there's bugs in the game, like people's heads are spinning around, or like people are falling through the floor, or maybe just crashes, right? Which is kind of the worst thing, that you lose your progress and you have to restart it. So those are called runtime errors. So a lot of those things are a result of bad logic. So it's a lot of things like let's see. Let's say for example that your game, you're making a Diablo clone, right? Or you're making a Skyrim clone, and you have like 10 inventory slots, right? You assume that the player's only ever going to pick up 10 inventory slots because, oh, I only ever put, let's just say you put like 10 items in the game, right? You made sure there's 10 items around because you know that you only have 10 slots for inventory. So you write all your code like, oh, it works great. I have 10 slots and the player can pick it up. The problem is that you didn't realize that you wrote the code so that sometimes monsters will also drop items too. So some player runs around, grabs all your items that you placed, and it picks up an 11th item, right? You didn't think about that because you're like, oh, I know I placed 10 items in a game. I have 10 slots. Why do I need to worry about 11 items? And he picks up that 11th item. There's all kinds of things that can happen, right? So because you didn't account for the fact that the player has done something that you didn't expect, now your program has kind of gone off the rails. Like it's kind of like gone rogue a little bit. Like it's like, oh shit, well, I don't know what to do here, so I'm just going to keep going and assume the best. Sometimes it results in bugs, like weird issues. Like maybe now that he picked up an 11th item, now you're not tracking them. Maybe he loses like the first item that he ever picked up, so you only ever see 10, right? Maybe the first item, it just gone into infinity. It's gone nowhere. It's basically gone and blinked out of existence. Maybe he picks up that 11th item, and it causes some other weird behavior. Maybe like that item now is like counted infinitely. Maybe you might have encountered some of these issues where they're called like cheats or exploits, like some way to play the game that isn't intended. And what ends up happening is that they kind of find a way to cheat their way out of it. Like maybe they get a lot more money than they're supposed to, or maybe they find a way to like kill the same enemy over and over and over again to like get the loot so you can sell it all. That's one way. And the worst way is that the program will be like, I don't know, there's 11 items here. You told me there were 10. I'm just gonna crash because I don't know what to do. I'm trying to figure out what that 11th item is. You only told me there were 10, and it grabs some memory from some location in the executable, and then just says, well, I give up. And so a lot of times when that happens, it just will throw what's called an exception, and then will shut down. Sometimes it'll shut down gracefully. I have seen programs just shut down like instantly, where you don't even see a dialogue saying this program has stopped responding or anything like that. Literally just, it's gone, right? Those are runtime errors. So those are the kinds of errors that you'll be fixing for the rest of your life as a programmer. Compiler errors, like you kind of get to the point where compiler errors aren't really a concern anymore. For you guys, for like the first like year or two, this is going to be like the bane of your existence. Okay, you're going to be like trying to remember the syntax. You're going to be trying to figure out why something doesn't work. When you build, it's going to be like, nope, I don't want to build. If you get a compiler error, you don't get an executable. That's the thing. You have to do all these steps in a row, and every single one of these has to work 100%. So you can't get here until you fix all your compiler errors. So that's going to be kind of the bane of your existence. You're going to be figuring out, what does a compiler error mean? Why is this telling me this weird thing? I just don't understand it. My advice to you guys is if you see a compiler error and you just have no idea, just take that error, copy it, Google it, and figure out what other people have run into that error and see if it helps you figure yours out too. A lot of times, you get an error that's like 50 lines long, and all you did was forget a semicolon. That's it. If you forget a semicolon, like above that block, so the reason why semicolons are important in C++ is it tells C++ that you're done with that line. It's like casting a spell. Whenever you're casting a spell, you have a certain set of words you want to say, and then you're done and say, go, cast that spell. If you forget the semicolon, it's just going to assume everything that comes after the semicolon is part of that original spell. It's part of that original thing that you're trying to do. Because in C++, you might not know it, but whitespace doesn't matter. Like how you add whitespace or how you put tabs, it doesn't matter. So even if you put lines of code on different lines in your text file, C++ actually just combines them all into like essentially one long line with semicolons in them. So if you forget a semicolon, then everything gets combined into one. So that's one. Linker errors, these are kind of like, sometimes I still have issues with certain linker errors. These are kind of the most tricky to solve because a lot of times you'll be seeing it and like, because I told you guys, this is not a problem with what you type. This is a problem with how you set up your project. A lot of times it's all about figuring out how Visual Studio wants something to be configured. And this is not something that is easily taught. It's kind of case-by-case basis. But the best examples I can give are, let's say you're trying to make something play a sound. This Damon was trying to play a sound in his Visual Studio project. And the problem is a lot of those things that you want to do with Windows require you to bring in some external code that someone else wrote at Microsoft. Like when I did the CD drive, I needed to bring in what's called a library because whoever wrote the CD drive opening code, I needed that so I could open it myself. And so that's where linker errors kind of come in. So you'll be solving those as well. Those will be less like, you won't really have many of these at all for pretty much this entire quarter, but you will run into this starting as soon as we start doing graphical stuff. So as soon as we start doing like drawing circles and squares and rectangles, we'll run into that. Okay, let's write our first program. Questions? Let's see if I can just do this while it's running. All right. So I'm going to do this. All right, can you guys see Visual Studio? Let me turn off the lights. Turn off the projector again.
Oh, good job, man. It's going to take like 2 minutes for you to...
Yeah, hey, what's up?
When do you do your break?
You know, I usually do them after about an hour and a half of lecture, so.
I'm just trying to line out like that.
You want to go? Just go for it. It's going to take me another couple of minutes, so just go ahead and turn it on.
I drink a lot of water.
That's all good. I'll wait for you. Yeah, whatever you need to do. It's all recorded too, so everyone knows I'm in the bathroom. Yeah, get Visual Studio 2015 up and running, please. Don't start any new projects yet. I kind of want to go over them in more detail today. Make sure everyone has Visual Studio.
We have 2013.
You only have 2013 installed? Are you sure?
Okay. So, I need to remember...
No, don't start with that.
See it?
Just go to start.
Change pictures. I want to be looking at my phone. I hate looking down.
Yeah, make sure you don't open Blend. Make sure you're opening actual Studio 2015.
What's the difference?
So Blend is a tool that comes with Visual Studio that lets you make UI. So it's just a way to basically author UI. We actually use it on Overwatch to make all our UI. It's kind of like Flash a little bit. I don't know if you're familiar with Adobe Flash. Or it's a way to basically put like buttons and like sliders and text boxes, arrange them, put animations on them, and then what it actually does is that's kind of like the front for how your program will look, and then you write C++ or C# behind it to actually make it do stuff.
Let me make sure I'm not calling things as long as I'm not calling things to an integer. Uh-oh.
Everyone got Visual Studio?
Do we have to name it anything or?
What are you guys doing? Don't make a new project yet.
Make sure there's no errors.
All they're going to do is just like edit it.
Alright, it still works. Good. That's fine. Oh, just written in that. Yeah, so, it's greater than?
It's the worst.
Now
they started doing like
greater than
It's like
int?
mobile gaming. They're like that.
Have the int be 0, right? Okay, so branches.
You should be good to go. Okay, I want to get everyone out. Let's get started with Visual Studio 2015 up and running. You guys are all good to go.
Which was set? Yeah, it wasn't working when he walked over.
Okay. Make sure this is still recording. Cool. All right, so we have Visual Studio. This is where I spend most of my life. I kind of went over a little bit about projects last week. I want to kind of review that. Visual Studio by default kind of gives you this splash page. Feel free to investigate whatever these things are. You can like learn about this. I mostly never look at this stuff. This is all kind of just like, this is a lot of stuff that you can use to like learn more about what's happening with Microsoft, what's happening with C#, but I don't usually use it. Most of the time I'm focused on making a game. So we're going to make a new project here. And you can either do that through this button up here, or you can go through the File menu up top and do New Project. All right. So what we're going to be doing is we're making an empty project. I went over a little bit about what these Win32 and Win32 console applications are. We're going to be just making an empty project because it's probably the easiest thing to work with. It doesn't have a lot of the extra settings and properties that you need to worry about. You can name your project. I'm just going to name mine week 1. And I'm going to have you guys kind of follow along as I do the first one. And then I'm going to have you guys do a little bit of exercises after that. So go ahead and make a new empty project. Name it whatever you want. All right. So we have our Visual Studio project now open. So when you make a new project, it actually makes both a project and a solution for you. So you can see both here on the Solution Explorer on the left. As I mentioned, a solution is a collection of projects, and a project is just a collection of CPP files and header files. So .cpp and .h files. You can have multiple projects in a solution. You cannot have multiple solutions open at the same time in the same window. So you only ever have one. So we have one solution for Overwatch. We call it game. It's just called game.sln. And inside game, we have about 50 different projects. Among them are all the servers that we use to run Overwatch, as well as the various engine projects that we have to actually, the engine that drives Overwatch, in addition to all the game code that runs Overwatch. So the first thing we need to do is we need to actually add our CPP file. So we're going to go to our source files. These different folders here, it doesn't really matter where you put them. These are more ways for you to organize. But we're going to put our CPP files here under source. We're going to add a new item. And here are the two types of CPP files that you work with in Visual C++. So we have CPP files and header files. If you want something to run, you're going to need a CPP file. We're going to deal with header files at a later time. So you can name this thing whatever you want to. I'm just going to keep it called source. Doesn't really matter, but you're going to add an empty CPP file. All right. So here we are. As you can see, I have text up here. Okay.
I can't do this because the Windows wasn't installed. He didn't have C++ like installed on this thing.
That's fine. You can follow along afterwards. So I want to show you the first program, and I'm going to type the first program out, but I'm not going to type all the other programs out. So I'm just going to show you guys the other programs, and we're going to basically do them in class as an exercise. But I want to go over the main pieces of the program. So this is kind of intimidating, right? It's like a blank text file. It's almost like a blank canvas. Like, what do we do? Thankfully, C++ forces you to write some code no matter what. Even if you're writing a simple tic-tac-toe game or you're making the next World of Warcraft MMO. I'm not saying that we're making the next World of Warcraft MMO. I'm just saying I don't even know what the World of Warcraft team is doing. All right. The thing is that when you're writing your C++ program, Visual Studio needs to know where does it start. Where is like the starting point of your program? It's not actually the first line. It has nothing to do with where you write your code. I could write my first line of code down here, but it's up to me to tell Visual Studio that it's like the first line of code. And the way you do that is by you declare what's called a main function. And a main function is kind of a standard that is used to determine, it's a standard across all versions of C++, whether you're making a C++ program for Mac or Windows. It looks slightly different in a lot of ways. There's a lot of ways you can declare main, but we're going to do the simplest way. And this is the same thing you're going to type pretty much every single time, no matter what program you're writing here in class. Every time you have a new project that you're working on, you're always going to do this first, which is you're going to declare a main function, which is comprised of 2 parts. The first is a return type. And I'm going to get into this. This is basically saying, hey, this returns an integer value. And what is an integer value? An integer value is a value from 0 to infinity, or negative infinity to positive infinity, effectively. There's actually is a limit to this value, which I'm going to get into. But this just says it returns a number, essentially. That doesn't have a floating point. That doesn't have decimal points after it. And why is this important? Why does it have to know that it returns a number? This is actually the number that your game tells Windows when it's done running. Okay? So when your game is done, whether it closed or whether it crashed or whether the person Alt F4'd your game because he's raging, this is the number that gets returned to Windows to tell Windows how it ran. And a lot of times Windows doesn't actually even use this number, but sometimes, depending on the program that you're writing, this is the only way to kind of communicate with whoever ran it to tell it whether it ran successfully or whether it failed to run correctly or not. For us, this isn't really going to matter because we're not going to ever use this number. We're always going to return 0. We're always going to tell Windows that 0 is everything's A-OK, that everything ran OK, which might not be true in our game, but we're always going to tell Windows that everything is OK. And then this is the key. This is a reserved word that is specific to C++ that says, hey, int main, that is where our program starts. All right? The other part is that this is what's called a function. We're going to get into more into functions next week as well. But we always have to have a function that has a set of parentheses after it in case we might want to pass something to that function. All right, so if you type a parentheses, it should kind of autocomplete that stuff for you. And then finally, we're going to tell C++ where is the start and finish of our function. And so you're going to get very used to writing these, and these might be even familiar to some of you. C++ uses a lot of curly braces to determine where something begins and where something stops. Otherwise, C++ doesn't know where it starts and stops. So I want to talk a little bit about this, but the curly brace is right next to P. If you hold down Shift and press that, Visual Studio will actually close the curly brace for you just to make it easy. So C++ uses curly braces to determine where something starts. Right here it starts. I'm actually going to turn on line numbers real quick here. So my program, I'm telling it that it starts from line 5 and goes down to line 11 because that's where the start and stop of our curly braces are. C++ uses curly braces, C# uses curly braces, JavaScript uses curly braces, so a lot of programming languages use them. Some programming languages don't use curly braces at all. Some programming languages like Python use how far from the left it is instead of curly braces to tell you where something starts and stops, which is kind of weird. It actually uses how much white space you put in, how many spaces you put in from the left to determine where something starts and stops. I personally prefer curly braces, so this is where the magic happens. So right now it's just a cute little program that does almost nothing. This can grow into something major like Overwatch. Overwatch has a main function as well. Okay, there's some place in Overwatch where we have something like this. I wish I could share with you guys what that is, just to ground you guys. Our main function is actually, like, you would think it'd be huge for Overwatch, but it's actually pretty tiny because you try to put as little in that function as possible. What actually our main function does is does some bare minimum work to figure out what you're trying to do with Overwatch on startup, and then tells all these other systems to tell them to start up and start running. And I think our main is probably, I'd be guessing here, 50 lines of code, maybe 50 lines of code. And then that basically it's like setting off an explosion, right? You have like a fuse. Like you don't have to light every explosive by one. You just set a light and then everything kind of goes. That's exactly what happens. You can basically trigger the rest of your entire game from this just by using a few lines of code, which then branch out and do a bunch of other cool stuff. All right. Okay. As I mentioned before, we have to tell Windows how our program ended, so we have to tell it whether it returns 0 or 1 or if everything's okay. And the way we do that is we're going to return to Windows a number, so we're going to return to it 0. And we're going to finish off that line with a semicolon. All right? This line right here has to be the last line in your function in main, because nothing else runs after this. When you tell C++ to return, it says, cool, I'm done with you. This is basically the last line. So if I write anything else here, none of this runs at all, because right here is where it stops. Even though this is basically where my function starts and stops, as it's running through the program, it's going to get to here and stop. So I'm going to step through this. I'm going to write out the rest of this real quick, and then I'm going to explain all of it. What should we say? Do that. You can type whatever you want to. And then I'm going to do this up here. There's a lot of stuff that I just typed, so I'm going to go over each of them. I know it's like immediate, like, oh man, there's so much stuff here. I don't understand like any of the specific pieces, but the best part is that you're going to be using these a lot. So we're going to be doing this a lot as practice too. So. All right.
Professor?
Yeah. Yes.
Do you need spaces in between where it says count and...
No, I don't know why Visual Studio puts them in, but you can do this. You can even do, watch, you can even do this. And that's okay too. That actually is the same exact program. There's actually this this contest that I want to show you guys. Hang on. I know you guys are trying. There's this contest for writing what's called obfuscated code. And what's the best part is that you can see here. That's a program. Some people do like programs all in like that. They do it in a shape like that. So that's a DNA, or that's a, I guess it's like DNA or RNA. Chromosome. So you can do that. That also compiles. I think this is Mario. And that all compiles too. That's not just gibberish. That actually runs. And what that one I think does, what does that one do? Looks like it's actually a game where you play Mario. All right, you run that, you compile that, and you actually get Mario out of it. So yeah, Whitespace doesn't matter. Okay, so I want to talk a bit about all the pieces of this, because these are like, I still use these a lot. The exception is I don't use cout, and I'm going to get into that in a minute. So let's start with like lines number 1 and 2. So those are actually colored green specifically because those are called comments. Those are things that the compiler ignores, so you can write whatever you want to in there. It's basically kind of like you can ignore what syntax is. It doesn't care. If you put 2 slashes like that, everything in front of it will be completely ignored. You can even write poetry in there if you want to. I don't know. Some people write like really long rants. It's kind of funny because those are comments and those are ignored, and those actually don't have any effect on the game itself. They have zero effect. They're a way to communicate with other people about what this code is doing or why it's doing something like this, or if you just want to bitch about how long you spent making this thing work or why this thing doesn't work, you can do that here. And what's really funny is that, we have about 30 programmers and we're all collaborating with one another. And so we're always reading each other's comments. Nothing is private when you're working on a game if you're writing in source code, right? So anything that you write in a file, in a C++ file, can and will be read by someone later down the road. And it might be you, it might be some other person. And comments are a way to share information. They're kind of like like posts that you might make, right? Like a Twitter post or something. Like where you make like a comment. You're not limited by the number of characters or anything like that. These specific comments force you to do it on one line, but there's another type of comment that you can do on multiple lines as well. You can do multiple lines like this. These are anything that you put here, in between here, will be considered a comment. Everything in between there will be considered a comment, okay? That's the other way you can do it. And comments are actually really important. Everyone always says this, but commenting is a hard thing to get right. For now, I'll be happy if you guys do any comments. For the most part, I fully expect you guys not to do comments at first. It's something that I feel like you should strive to get better at, because that's really what separates the good programmers from the mediocre programmers, is people that understand that this code that you're writing is not really even yours. I mean, you wrote it, but a lot of other people need to look at it and read it and understand it. That's how you make games, right? Like, unless you're making a game by yourself, you're collaborating with other programmers. Other programmers need to be able to understand your code, which means they're going to be reading through it in a way that might not make sense to them. But if you put a little hint for them to make it easier, then they'll have a much better time of knowing what your code is and why you did something. One of the best reasons to comment is actually to explain why you wrote it a certain way. And that's probably the best comment you can write, because a lot of times, and it happens a lot, Overwatch has been in development now for almost a little over 2 years, I want to say. And in that time, I wrote code 2 years ago. How many of you guys remember like what posts or tweets you made like 2 years ago? Or like why you tweeted something? I don't. How about 10 years ago? No, I don't know if you know that. You're just raising your hand. Just
I didn't.
Oh yeah, give me one tweet that you wrote 10 years ago.
I didn't. That's the whole thing. I wasn't into that stuff.
Okay, there you go. If you don't write anything like Damien, then you don't have to worry about it. The key is that I don't think Twitter even existed 10 years ago.
No, it didn't.
So the key is that the reason why that's important is that when I talked about those runtime errors, you know, the fallout bugs and stuff that you guys run into, or like problems with why something crashes, a lot of times it's from code that was written a long time ago, right? Like that crash might have been in there for a long time, just waiting, like a time bomb, ticking. And then it explodes, and you're like, oh crap, well, we got to find out where it is in the code. You might track down the exact line of what's causing it. Like when I talked about the inventory example, like, oh, it's because the inventory only has 10 slots in it. Wait, why does it only have 10 slots in it? Why does it not have like 100 or a billion? Why wouldn't we just change this to be 20? Let's just change it to be 20 or 50 or 100. Wait, we can't just change it to be 100 or 50. Maybe the reason why they made it 10 was because the hardware can't support any more than 10. So if you change that thing to be 11 just to make it work, as soon as you commit that, there's a chance that that might just shut down everything. Like that might cause a crash for everyone playing your Diablo clone right now. You don't know the ramifications of it. If someone put a comment next to that inventory slot that says, hey, I'm setting this to 10 because if you do not raise this above 10, because if you do, you will cause everyone playing this game to suddenly crash because the servers can't handle it, right? No one knows that. If you didn't have a comment there, you would have just raised it up to 11 because maybe that guy that wrote the code doesn't work there anymore. Maybe that guy is not there right now. Maybe he's not at his desk. Maybe he is on vacation. Whatever it is, you need to fix this right now. So a lot of times you're working in someone else's code. It's kind of weird, right? Like a lot of times you might be working on something that's like yours, and like it'd be weird to have someone like come over there and like, oh, let me fix that up for you. Oh, I fixed this up for you while you were out. Don't worry about it. You know, or like you're working on homework or you're taking a test, you get up to use the bathroom. Someone is sitting at your desk like filling in problems for you, right? It's kind of like that. Like the thing is, it works best when it's a collaborative thing. There's this thing called open source development that's happening a lot more. It's a way to write programs that allow all these people to work within the same code, and anyone can contribute. It's kind of like Wikipedia. You guys know that Wikipedia, anyone can edit, right?
Oh, yeah.
Like you guys can just go in there and add whatever it is. So you can go in there and edit someone else's article that they wrote because you might know more about it, or you just want to troll, or whatever it is that you want to do. It's the same kind of thing for C++ and programming. Other people, you want other people in that code. You want other people helping you write it, even if you're not there. And the way that you do that is you make comments, okay? I don't really want to downplay it because it's so important. Like, the shitty part about programming, like, it's not really a shitty part, but like, it's something that you have to learn to get over, is the fact that you're staring at this kind of stuff all day. And sometimes that kind of stuff, like I showed you guys the website, right? And God forbid that any of these programs here, you run into them. Oops, that's actually a standard program. Any of these you run into, and you see this somewhere, and there's no comments anywhere, right? But if there's like one line at the top that said like, oh, this just runs this thing. It just does this thing. Maybe it simulates a DNA replication. I don't know, or simulates a virus, whatever it is. You can actually see a pound include at the top, which is funny. So you can actually see there's one thing that it's doing that you guys might be able to recognize. You look at this kind of stuff all day, maybe not in this format. So comments are a way to inject a little bit of humanity into what's normally like just programming and kind of a little bit dry text that you might see. And it can be funny because we're all like people, and we all have senses of humor, and we all have interests and passions. And sometimes that can only come out through how you comment something. So we have a lot of people that might make jokes and stuff while they're in their comments. All right. Questions on comments. So feel free to add comments on it. It's kind of weird right now because it might not make sense to add a comment because you're the only ones working on it, but that's why we use them. So if you ever looked at Overwatch code, you'll see comments sprinkled everywhere. All right. Whitespace. So as I mentioned, C++ will ignore all blank lines. So even though there's a blank line on line 4 and line 3 and line 5, C++ does not care. It can make it more clear to have whitespace by separating things. So for instance, this is more clear than kind of doing this, right? That's a little bit harder to read, right, than putting in whitespace.
It ignores the spaces too, right, between characters?
Yeah, it does here, but it does not ignore these spaces or this space. Like this is an exception. You can't do that. You can't like combine int main. So you have to separate the words apart from one another. But statements here, as long as there's a semicolon here, it's okay. So remember what I said about semicolons are important, because if I deleted that semicolon, it treats that entire thing as one line. It's as if I wrote this all in one line like this. So that's what C++ does. It basically gets rid of all the white space. All right?
Same thing with arrows.
Sorry, the arrows? Oh, these?
Yeah.
You can put, there's white, you can actually inject as much as you want in here. That's the same.
And in between, like, the coup. Right?
In here?
Yeah.
Yeah.
Or, I mean, those, yeah.
These two, you cannot inject spaces in here.
I mean, between coup and those two.
Oh, here? Yeah. You can do that too.
You go on the other way.
Yep. So you guys get it. For the most part, whitespace doesn't really matter. It's more for your readability.
Yeah.
There's a few things where you do have to separate, like this has to be separated. You can't just make everything just one long continuous thing. But the key is that I try to like add whitespace where it makes sense to kind of, it's like paragraphs, right? Like, you know, put paragraphs in what you write. Don't like do one long run-ons. And like some people might do one long like paragraph, but I try not to do all this stuff. All right. Okay, so let's go to line number 4. Pound include Iostream. This is not hashtag include. This is a pound include. That pound symbol is a special symbol that tells C++ you're going to be, it's called a Preprocessor Directive. And what that means is that when I go back to my slide, there are steps that C++ takes before it runs your compiler. There's actually like a hidden step here in between these two. And that's what those pound symbols let you do. A pound symbol in front of something means that, hey, this is going to run right before it compiles. So it's going to do an extra step. And so that pound include that's in Visual Studio is going to run before it actually even compiles. It's going to do something, and then it's going to compile. So what this thing is going to do is going to take another file. So include means take another file, take all the contents inside that file, and put it right here. Replace line number 4 with everything that's in that file. All right? That's what it essentially does. Because this file has the ability to use these right here, which are a way to write something to the screen and a way to do a new line. Iostream is part of the standard C++ library. So C++ is more than just like functions and returns and stuff. It also includes what is called the standard library. It's kind of like if you buy a car and there's a basic version of the car that just lets you drive it, and then there's like the version of the premium edition, luxury edition that has all the options and features in it, like rear view cameras and high beam, like xenon lights and whatever you want, like 19-inch rims, whatever you want, all those like nice features. The standard library in C++ gives you a lot of those features that help you make your game. So C++ is both the compiler as well as that library of functionality. So this right here lets you write out stuff to the black and white console window, which we're going to run. Okay. So this right here that you include, this is called a header file. You typically put at the head of your Cpp file. That's why. This used to have a .h on it. There's actually a file. There's literally a text file that's called Iostream somewhere in Windows that you can open that has this in it. I think we can actually go to it. There we go. This is what you're copying and pasting into your Cpp. This is part of the standard C++ library. It includes other things. So notice here, it also has a pound include. Okay, it includes all that. This is what you get, right? It includes another one, and another one, another one, all these, okay? So you're basically including all of those, including all the ones I didn't open, all right? These are all files that live, let's see. Looks like they live in Microsoft Visual Studio 14 VC include. So this is where all those files live, okay? So it's not anything crazy special or hidden. These are literally files. If I deleted this, that would be a bad thing.
So what exactly does Iostream do?
So it gives you the ability to do write out to the console and read in from the console when you type in something. So it has all of these functions declared for cout and cin that gives you the ability to print something out to the screen. Now, if you didn't use Iostream, for instance, let's say we tried to do that on our own, we would essentially have to write the equivalent of what's here, like all this stuff, by ourselves from scratch, which you can do. So cout will also do things like the Iostream will also let you print almost anything to the console. So we're going to get into a little bit of difference. So we actually don't use Iostream on Overwatch. So it's like kind of crazy because it kind of includes. We tend to try to shy away from a lot of these standard libraries because we want control over them because we're making console games. When we're making a 60 FPS shooter game, which has to be super fast, there's a lot of files involved in here, which can actually slow down your game when you're using them a lot. We don't know how these things are implemented specifically. So we actually don't use these. We actually use, if we want to print something to the console, there is another way to do it. It's kind of like the difference between a manual transmission and an automatic transmission. Like in a car, like you can do the same thing that Iostream does. You can write stuff to the console, but you have to do it using the built-in, like the super rudimentary stuff that's not in the standard library, which we use what's called printfs. So printf is another way to print something out to the screen. We'll get into that later. We're gonna use cout for now. Yeah, we're gonna do two different things. All right, so now you know it's basically taking all that stuff that's in those files that I showed you and pasting it into the CPP file. All right? That's what that's doing. That's what's doing behind the scenes. Thankfully, you don't have to think about that. You just do this, and it'll take care of it for you. All right? I talked about int main. So int main is actually it's a function. So something outside. So when you double click that exe, Windows is actually saying, "Cool, I found your main function, bro. I'm going to go ahead and do whatever you told me to, and then when you're done, let me know." All right? So it calls int main. It does whatever you told it to, and this is how you tell Windows that you're done with your function. You do a return. All right? And all of them always have to have a pair of parentheses. Any function has to have a pair of parentheses. We're going to be writing more functions later. Yeah?
So the STE count for the quote, would that be only used for if we want to put like wording into
The black and white console window, yeah. So if you're talking about, like, let's say you want to show like ammo count or health or something in a game, we're not using this.
okay, so
This is only for these text-based games that we're doing. Like, if you want to draw ammo count or health or inventory names or stuff like that, you're not doing this. In most cases, what you're doing is the way that text is drawn in like games is like you're literally like drawing pixels on the screen. So you load in a font. You're saying, hey, I want to draw the letter or the number 100, right? Like numbers 100. You actually have to render 100 on screen, like either big or small. You actually draw them on screen on what's called a quad. So like you render a quad and you slap a texture on there that you created with data that represents the number 1. It's kind of a little bit more crazy. Thankfully, in like Unreal and Unity and all other games, and even in Overwatch, if you want to draw something on the screen, usually you just like there's like an easy function that lets you say draw this text on screen. Or in our case, we use Microsoft Expression Blend, which is like Adobe Flash. It's a way to basically put buttons and stuff in our game. So all our menus are done through that. But yeah, we're not going to be using this once we start getting into like the visual stuff.
okay.
So this is all just for the text-based stuff. Right, so there's the function. Okay, so I talked about the curly brace and how this is where the function starts. This is where the function ends. This right here, in between here, is called a block of code. You can define multiple blocks of code within other blocks of code. And this entire thing here is called the body of the function. So the entire thing that makes up the function, this whole thing, curly braces and the text inside of it, is called the function body. All right. I'm going to break this down more. I swear I'm going to give you guys exercises too. We're going to get into this right here. This line right here, when it runs, will print something out to the screen. So this prints out welcome to SDVA 103, and then prints a new line. It basically is as if you press enter, and it goes to the next line. This right here, within quotes, that's kind of colored differently, is called a string. It's literally a string of characters together. It's called a string literal because of that too. So this thing here is basically something that can't change. It's always going to say this thing. We're going to get more into strings and string variables soon too. So the way this thing works here, this is basically a cout here, and double colons here, and standard. So I want to break this down a little bit. So first of all, this right here, this cout is actually something that is like a living, like not a breathing entity, but it's like a thing in your game. If this is considered our game, which just prints out one thing and then shuts down, cool. This right here is kind of a living entity in our game, and it's kind of hanging out. We just created it from nothing. We like spawned this thing that's called cout, and we're telling it, hey, I want to print SDVA 103. If you look here, look at the direction of the arrows here. They're actually pointed this way. We're pumping this that way into this object. We're kind of taking this string that we created and putting it into this object. All right. Same with this. We're putting both of these here. These arrows here indicate I want to dump it into this object here. Okay. Look at the direction that they're going. It's kind of like a funnel where it's taking these characters and funneling them into the cout. So that now that cout has had these objects, these strings funneled into it, it can then print them out to the screen. And in this case, it'll be the black and white console window. So standard here, STD, It's not a disease. It is the standard library. This is what's called, if you see this with double colons, if you see anything like this, like double colons next to it, this is defining what's called a namespace. C++ has namespaces. I like to think of them, it's a lot easier to think of them like folders in Windows. Like it's a way to like figure out where this thing lives. So if I ask you guys like, where do your Steam games live in Windows, right? They live in a bunch of folders somewhere. Like maybe your Steam games live in something like, I don't know, C colon, users, maybe Keith, documents, Steam games, whatever, right? Something like that, right? That's where kind of Steam games live if you've ever seen them. Or like your pictures might live there under documents. So the equivalent would be like users, Keith, documents, Steam apps, and I don't know, I'm going to play like Cookie Clicker. So that's kind of what namespaces are. And namespaces work like that too. You could have multiple namespaces in there. It's a way to break apart something. If I had Cookie Clicker on some other folder, right? Let's say I had Cookie Clicker also installed on my desktop. Those are two different copies of Cookie Clicker, right? Like these two here. Like I have two copies of it, or if you have two pictures with the same name. You know how you can't have two files with the same name in Windows in the same folder, right? Like it always like does _1 or something if you're copying it. Well, the reason is the same in here. That's why we use namespaces in C++, because maybe I have two things named the same, and I need to distinguish between the two. And that's why I have this. There might be some other program out there, some other game out there, that has something called cout in it already. And the only way that we can live in a world where like hundreds of thousands of programmers are all programming at the same time is to distinguish between what's ours and what's theirs by using these namespaces. So you can think of the standard as kind of like a folder. It's called a namespace, but it means that this object here, cout, lives in the standard namespace. Okay? Just like how Cookie Clicker lives in the Steam Apps folder, and Steam Apps lives in documents, and documents lives under Keith, and Keith lives under users, right? That's why we use namespaces. That's why you see this. Same thing for ENDL. That's an end line. That object lives in a standard namespace. All right. Questions on namespaces? We use this a lot. Like this is how you declare. Like this, you're going to be using this when we get to object-oriented programming as well. It's a way to basically say that you can have duplicates of things. Yeah.
So what about using namespace, like under Iostream?
Good question. So let's say you're doing this a lot. Actually, that's going to be the next example too. We're going to get into that. It's a way, if you have to do this a lot, like std : like every time you do this, it might get a little bit tiring. There's a way to make this easier so you don't have to do this every single time. And I'm going to get into that. All right. And this right here is just basically like you press enter on the console. Okay. I'm going to delete these because these won't compile. All right. Questions? Any other questions? Anyone lost yet? Does this make sense so far to people?
Yeah.
It's a lot to take in. Note the semicolons here again. At the end of every statement, you want to put a semicolon in there. I talked about return here. All right. That should be it. So let's get through the steps of compiling it and running it. So there's a lot of ways you can compile. You can click this button up here, which will start running your game, and it'll ask you if it wants to compile, like this. I'm going to say cancel, because most of the time I go through the build menu up here, and I build the solution this way. And at the bottom of your output window, it'll tell you what happened because of that build. So here, it says build started. Source.cpp is getting compiled. And then here is what it generated. This is the executable that it generated. If I go to this location, I'll actually see the executable. You guys should have seen this too. This is my executable, right? There's my little exe file that I made. and I can double click on it. And weird, it's like closing super fast. That's okay, because we're going to fix that. And we can also click this button here, and it does the same thing. Okay, so there are two ways I'm going to show you how to stop this from happening. One way is the old school computer science way, and another way is my way of showing you this, which is going to be using the Visual Studio Debugger. We have this fancy Visual Studio. Why don't we use some of the features in it to help us figure out what the heck's going on? Okay, so the easiest way to do this, and I know the book makes a batch file. Don't make a batch file. You're not going to be making batch files to run this. The easiest thing to do, the things that I've been taught, is you have to have the program wait a little bit. The reason why it's running and closing right away is because it's writing this out, says, cool, I'm done, returns to Windows, and the Windows says, oh, you're done. All right, I'm just going to shut you down then. I guess you don't need anything from me. But we don't even get to read what we wrote, right? You can actually maybe see it for like a split second up there. So there's two ways. One, we're going to do standard cin. And I'm going to say what's called a dummy variable. I'm going to do this. This looks a little weird, but this is a variable that we're declaring. And we're going to get to that in just a second. But we're going to put this at the bottom of every single file that we do. The reason why is that now when I run this, it's now waiting for me. Okay? And if you guys are getting errors or anything like that, double check every line looks like this too. I'm sorry? Get dot what? Sorry, let me come over. Oh, okay, yeah, you can do that too. That's kind of the same thing, but you can do it this way as well. This is one way to do it. This is just so that the programs don't close. Yeah.
Yeah, mine is the end one is not.
It says L.
Is it L?
And then you need a semicolon here as well.
Some of you guys are running into your first compiler errors, which is good. Yeah. E and DL, yeah, that's right.
See, it shouldn't continue counting. Why is it continuing?
Oh, yeah. So that's the function. You're right. So this function has I know they still able to take it.
Oh, I have like a semi non-working code.
I want to declare a variable.
I mean, it's semi non-working.
Yeah, do you need help?
Well, I did the
It is now. Oh no, because it works. Well, see, yours doesn't look like that. That is what's dumb. The good thing is I have the problem is there's no way to tell it once I let go of sprint to stop straight sprint.
Building it, we'll build it all.
So I made some workarounds.
I like to separate
Okay, workaround. Okay, you ready for this, Steven? Ready for this? Okay, so stamina's draining, right?
You have to do both.
Right, it's draining. Let go. We're actually going up now because we're regaining stamina so fast that it beats the counter. And see, now stamina's full, which is the good news.
after I built it.
So you got the cheat
The only
sheet.
problem is it keeps doing that because I can't pick up the stuff. Okay, so come here. Okay, yeah, come here.
That's the license.
So-
We're trying to get as good as we can.
So when you play it, the moment you start sprinting, it starts making a counter so it knows when to stop you. So as long as it keeps running, it's going to keep dropping until you reach 0 before say it can't run.
Yes, so every time you write code, anything new, you have to build it. Sometimes building it, you won't. Don't worry, you won't forget to build it. It'll tell you if you try to run it. Building and having patience is kind of the life of a programmer. This is really simple. It builds in probably 1/10 of a second, right? You can't even see how fast it builds. Building Overwatch from scratch without any help takes about 17 minutes. So if you make if you're changing, and it changes, that time changes depending on where you're writing code. If you're writing code somewhere that's used everywhere, it takes about 17 minutes. If you're writing code that's only used in a specific spot, it takes about, I don't know, 30 seconds to compile Overwatch. So every change that you make takes about 30 seconds. There's ways to shorten that, but yes, you have to compile it every time you write it. So what did we just do here? What did we just write? So this is interesting because we just did 2 new concepts here. One of which is this line here, int dummy, and maybe I'll call this thing, I'm going to call this thing not dummy. Let's call this thing like, I don't know, player level. I don't know, whatever you want to call it. And I did something there. This is what's called a variable, and I mentioned it earlier. These are really important in C++ because they're the way that you store data. And so we're going to be writing this a lot, but a variable basically has, for now, a variable has 2 parts. They're pretty simple. In order to make a variable in C++ to store something, like, let me give you some examples of variables in games, okay? Variables in games are used to store things like player level, right? Like I have here. They also are used to store things like player health. I have 50 health right now. There are stored things like stats, like I have 12 strength right now. Or things like, where am I right now? Where am I in the world? So I am at position 12-12, 18, right? They're used to store how fast you're moving, right? They're also used to store like how many things you have, like how many objects in your inventory you have. How much ammo do you have right now? What weapon am I holding right now? How many kills do I have right now? What rank am I? Other things are stored. Who am I talking to right now? Am I dead? Am I alive? Am I male or female? All these things that store information about you as a player or something about the world in the game are used by creating variables. You store them with variables. And there's 2 parts to a variable. One is the type of the variable, and the other is the name of the variable. Okay? So you need to have both. You can't just have one. Those are the only 2 things that you really need to have a variable. Those are minimum things. And you have the type here, which is on the left. That's called an integer. We already actually used it up above in the function. We said that our function returns an integer. This and this are actually totally different things. Even though this looks similar to this is saying, hey, I have a function called main, which I said you have to have one of these, and it returns an integer. It returns a number. This is, hey, I'm going to create a variable called player level, and it stores a number. A player level usually is from 0 to like whatever, 60. So like it's 0, 1, 2, 3. You usually don't have like 1.5. Like you can't be level 2.6, right? You either are level 2 or you're level 3. You might be halfway on the level 3, but you're still level 2. It doesn't count, right? Just like how in the Olympics, like even if you're 1/10 of a second behind, you're still 2nd place. There's no, you can't get like 1.1 place. Yeah. So.
If you're creating a variable, it doesn't need to be in the main function, does it?
No. So I'm going to get into like where variables can live. Variables can pretty much go anywhere, but where they go affects how they can be used. So in this place here, I'm using them in the function. Like I'm putting this. You see here, it's inside the curly brace. What that means is I can only use this variable inside the curly brace here.
Okay. So you can declare it outside and still use it inside.
Yep.
But you can declare it inside.
Yes, but you can't use it outside it. You can almost imagine it's like a room here, right? Or like this right here is only visible to things inside the curly braces, but if I put it outside the curly braces, everything can see it. We're going to do more of that too. Part of your homework is going to be to use variables a lot. So I have a type, which is player level, and then a name. The reason why I have this, why did I have to make this? Well, I'm using a Cin object now. Look at the direction of these arrows now. It's going into player level, right? So you see here, these direction of these arrows are going into the cout object, and these are going that way, because this is coming from what you type in. Okay? This is basically saying take whatever the player types in and shove it into this variable, whatever it is. And that's important. That stops our program because now our program will wait here. It'll wait here until you type in something, and then it'll continue. Okay? So the way that our program works might be a little confusing because I haven't really talked about what happens. It might be a little obvious that it goes from top to bottom. But I want to show you guys another way to do the same thing using Visual Studio. And hopefully, it'll also make it a little bit more clear what's actually happening. Okay? So I'm getting into a topic that isn't really, I don't know why, isn't really taught in books at all. I think maybe it is because there are books on Visual Studio, but a lot of times when you're learning C++, you don't learn Visual Studio as part of it. They don't really care the fact that you're using Visual Studio. So I'm going to teach you guys some of that. So you can stop debugging. And we're actually going to just delete this here. So we're back to where we were before. And you can save that code because you're going to want to put that code in elsewhere if you want. What we're going to use instead is Visual Studio gives us the ability to, we are the masters of this program. We have the ability to bend it and shape it to however we want to by writing the code. But Visual Studio will give us even more control over that. Visual Studio is kind of like a master key. It's like a cheat code or cheat, like, I don't know if you ever run those, there's like some games that you can turn on like developer mode and you get all these buttons and stuff that you can like use to cheat your way through the game. Visual Studio kind of gives you the way to control everything about the program. So I'm going to do something here, right here. There's this gray column right here. And that's not just because Visual Studio has like a margin or anything like that. That's actually interactable. You can actually click on that margin over here, and a red circle shows up. That's interesting. So you're actually doing it per line. This red circle is very important. I would say that like a game programmer's job is probably like 20 to 30% writing code, like 50% debugging, and then like, or maybe like 40% debugging and the rest of the time spent thinking about writing code or talking about the game. That little red circle there is the key to understanding how your program runs as well as how to fix all these crashes and bugs that I keep talking about. Okay? That right there is a way for Visual Studio to tell C++ when it's running, hey, stop running when you get to this line of code. So let me show you what it actually does. So I put what's called a breakpoint here by clicking here. You can click on it to get rid of it as well. F9 also adds breakpoints. You can also toggle it off. You can disable it or enable it. You don't need to worry about that so much. But I'm going to put a breakpoint there, and I'm going to run. OK. So what happened? I ran, and if you take a look over here, our console window is still up. Right there. It's still running. The program actually hasn't shut down yet. And if you see back in Visual Studio, you see a little yellow arrow next to the line of code that is about to run. And now, I really want to show you guys this because this is a way for you guys to understand more about what your program is doing. And this is important because you can put this breakpoint anywhere. So let me show you guys what I mean. So I can put this breakpoint right here, right in the beginning of this curly brace. And I can run. All right? So it stopped. So if I look at what my program has right now, it's blank. So there's nothing actually in there right now. And using arrow keys, like using, there's like these buttons here, or using function keys. So you can do this. I can step. So you see how that yellow arrow moved down? That is how C++ is running through your code. As I step through here, See how that yellow arrow is moving? Every time I go through, so I'm going to restart it. Yellow arrow moves down, right? That's what our code is doing. Although it's doing it super fast, obviously, and I'm doing it one line at a time. This is what lets you control it. And so I'm going to keep this thing open here on the right so you guys can see. I'm going to make Visual Studio here on the left. So here's Visual Studio. There's my, make this thing a little bit smaller here. So if you look on the right, that's what our console has. And if I click, or if I step through, I'm going to step one at a time, that yellow arrow indicates what it's about to do next. So nothing there yet. If I step one more time, as soon as it ran that line of code, it printed it out to the console. All right? And then that finished. And if I hit F10 again, it'll keep going until it's finally done with everything. So I just keep going, and then finally it finishes. So this is one other way that you can stop your program from closing. If you put a breakpoint right on the return statement and run it, you'll get a window that stays open until you tell it to stop. And if you ever want it to just keep going, just click continue up here, and it'll just keep running normally, and then it'll close. Okay. So I really want you guys to learn about debugging, because I feel like part of learning programming is understanding why something is doing something, or why your program is doing something, whether it's right or wrong. And these breakpoints can help you figure it out. So, yeah.
I don't get an arrow. I just get a. Did you build your project after you?
So if you close it, and then you go under build, and do build solution. And then, yeah, run it again. Looks like.
Oh.
Yeah, you're not editing the right file. This is the file we're looking for. This is the file that's running. Oh. Yeah, so this is where you want to put breakpoint. Did everyone get a breakpoint working on their Visual Studio? I want to see your breakpoints working. Are we still installing?
It's not gonna be done.
You want to move machines?
I don't think there is.
There's one over there.
It's fine. You put a breakpoint in?
The gray column right there. Yeah, let's yellow. That's right.
We can actually stop right there. Okay, and then I would just build this one to the solution.
You're already running right now. It's running right there. See there, that weird icon right there? That's your friend.
Is that first if you want to run
Yeah, for you put it at the beginning.
Yeah.
Here, you use these buttons here. That little curve. Yeah, put it down. Put it one more time. See, now your arrow is at the same place that his is. His yellow arrow is like inside the circle. But yours is right there. So if you were to do the same thing, so here's a trick. I think the one that works. Align them. All right, breakpoints. Yeah.
So you said the breakpoint's supposed to stop.
Don't do Control F5, just do F5. Stop. And then it's running in the bottom. Did you click the arrows?
Yeah.
It's fine.
I forgot. I don't know how to.
It just took you to this random file. If you ever just that, just go to your solutions for
I got the pause.
You're like in this.
Okay, one of the other classes where we made a game and it beat me, and I wanted to bring in the code and see if you could fix whatever I
Okay.
or take a look at it.
Okay.
It's,
Bring it in.
It's really confusing.
Okay. All right, bring it in. That's fine. You guys all got breakpoints working, or you tried to at least? So, if you want to become a programmer, or if you want to do this, you have to learn this. There's no programmer, and it's weird because they don't teach this in school, but they expect you to be good at it. This is how you solve bugs. Like if I'm fixing something in let's say, let's just, for example, let's say there's a bug in how cout works, right? So I might be here somewhere. I might be looking at all this code and trying to figure out what's happening. I can't do that if I'm not using Visual Studio to help me, all right? And breakpoints are a way to help me. I can actually look at all of these variables that are on there and I can investigate it. And I'm going to get into that later. I don't want you guys to get scared off by this, but just know that we are going to be learning Visual Studio as part of like learning how to program here too. All right. If you ever want to get back, just double click on your file here. You don't want to get lost in the weeds with all the other ones. Okay.
Lost in the library.
Yeah. All right. So that's kind of it for that. I think we should take a break for now. I think we should take a half-hour break and then resume and come back and finish off the rest of the lecture.